Here is a presentation on the Universal Design Before and After project. This specific lesson relates to equivalent fractions. My name is Michael Scott. This is for EDTC 625 for Dr. Christopher Schamberg. Here is the objective of the lesson. Students are going to be able to create and identify equivalent fractions by correctly producing 6 out of 8 equivalent fractions after reviewing the components of a fraction. This lesson lends itself directly to the Common Core standards 4.nf.a.1, which involves explaining why fractions are equivalent and also being able to recognize and generate equivalent fractions. Equivalent fractions first come up in 4th grade. They're used in 4th grade and they continue to follow students throughout, especially when comparing fractions, adding and subtracting unlike fractions, and converting units of measurement. Some background knowledge: students have to be able to understand what a fraction is, numerator versus denominator, and what both of those represent. They benefit from comfort with multiplication division facts, and they would have a quick lecture in the traditional form of how to apply the standard algorithm to generate equivalent fractions. There is a worksheet on the next slide. That's taken from Super Teacher Worksheets. It is a 3rd through 5th grade level, and it involves finding equivalent fractions. So as you can see here, the first 3 do have models. The rest of them are just the numbers. Students can quickly look, for example, at letter A. If you look in the 2 denominators to get from a 4 to an 8, you multiply by 2. So you do that to the top. So 3 times 2 is 6. So that means that 3/4 and 6/8 are equivalent fractions. They would go all the way through the worksheet, and they'd be assessed on how many of these that they got correct. Some faults in the traditional method. Okay, the standard does mention the use of models. The first 3 examples did have models, but the rest did not. Also, being able to just complete an algorithm doesn't ensure the students actually understand the concept as to why that algorithm works and what it's actually telling them. They're also not going to be very engaged by that worksheet. It's just simple numbers on a page to just fill them in. They're going to race through it as quickly as possible, and again, not necessarily be able to apply what they've learned. It also does not allow them to visualize fractions, which becomes a big part, especially when comparing them. Once we apply the universal design guidelines to it, the lesson changes. Students are going to be placed in groups of 3. Each group is going to be responsible to submit 8 sets of equivalent fractions on an iPad, and they'll use 4 different methods, which I'm going to go over in a little bit, to create those equivalent fractions from provided fraction cards. The fraction cards will have 2 fractions on it. One of them will be missing the numerator. The students will have to use the different methods to determine what number goes in that missing numerator. A few additional skills that might be required. They have to be familiar with an iPad. They have to know how to take a picture and a screen capture, which our students are familiar with. They have an iPad for every student in my school. They know these basic skills from technology class and also in other subject areas. They should also be familiar with unit fractions, fraction strips, and fraction circles, which I'll describe in just a second. And they must be familiar with smart notebook technology, which comes on the iPad, which students use across all different subject areas in our school. This is the activity itself. There would be a short lesson ahead of time showing those students how to perform each of these different methods. This would be the activity that comes at the end. Method number 1, they're going to use fraction strips. Method number 2, fraction circles. Method number 3, they're going to draw models in the notebook. And method number 4, they're going to multiply a fraction by a whole number also in the notebook. I'll describe each of these in greater detail right now. Method number 1 involves the fraction strips. Here's what the fraction strips look like before they're cut up. Students will need to create 2 equivalent fractions using these fraction strips. This is a picture of what the students would actually submit. As you can see here, they determine that 2/3 is made up of 2 of the 1/3 strips, and to make an equivalent fraction or a strip that's the same length, they would have to use 4 of the 1/6 fraction strips, so 2/3 is equivalent to 4/6. So they would fill in the missing numerator, take this picture, and it would be saved on their iPad. Fraction circles were very similar. Some students are better at representing or visualizing fractions with rectangles or squares. Some are better with circles, so this allows different strengths to use the different methods as well. Again, here's a sample of the picture they would submit. 3/5 they would determine that's equivalent to 6/10, and they would submit 2 of these pictures as well for the fraction circles. For the student model, sometimes they're asked to draw models to show that fractions are equivalent. Okay, they would use the smart notebook on their group iPad, and they will also use a screen capture to document their work. So here's an example of the screen capture. You can see that they drew the left rectangle has 4 total pieces and 2 of them are colored in, and the right rectangle, which is the same size, has 2 pieces and 1 of them is colored in. So they both have the same amount colored in, So they are equivalent fractions. They're just two different ways of drawing and modeling those equivalent fractions. Similarly, they'll use the standard algorithm. Instead of just multiplying the top by 2 and the bottom by 2, students are shown that they can turn that into a fraction, 2 halves. And it's also explained to them that when they're multiplying by 2 halves, they're really only multiplying by 1 whole. And they know that when multiplying by 1 does not change the value of a number, it just is a different way to represent that portion of the total shape that is shaded in. For assessment, each group is going to submit 8 pictures, 2 of each method. The iPads will be left on the teacher's desk to quickly review, and again, the objective is for at least 6 of the 8 pictures to be correct. Ideally, all 8 will be correct, but they have achieved their objective if they get at least 6 of the pictures to be correct to show correct equivalent fractions. This incorporates several universal design guidelines, numbers 2, 4, 5, and 8. Guideline number 2, provide options for language, mathematical expressions, and symbols. Students have to be able to justify and understand why there's an equal sign in between 2 equivalent fractions. They'll also continue to hear the term equivalent, and the more they hear it, the more they'll understand it and commit it to memory, and also show that equivalent starts with the same first 3 letters as equal, and they'll be able to explain why equivalent is just another way to say that their fractions are equal. Guideline 4, provide options for physical action. The groups are working at their own speed, so they can either take their time or work as quickly as they are able to do. Students are also using physical manipulatives, and they're using technology to assist them. They're moving the fraction strips and the fraction circles around. They're taking turns with the smart notebook. They're also using the iPad to take pictures and the screen captures to show that they accomplished the work that they were asked to do during the group time. Guideline 5, provide options for expression and communication. Again, they're using the manipulatives. They're also able to draw pictures, and they're able to use the numerical formulas. As mentioned, some students prefer one method over the other. Sometimes they're asked to use a specific method, so I would like them to be familiar with all of them, but unless it specifies which method to use, they're able to use whichever method works best for their brain. They're still going to get the same answer each time, regardless of the method. They also have the 2 different types of manipulatives. Again, the fraction strips or the circles. Some students prefer the circles, some use the rectangles. That's kind of a personal choice for them. Guideline number 8, provide options for sustaining effort and persistence. They're working in groups. Hopefully, the groups are encouraging each other. They're sharing the work. It's not just one student doing all the work. Teacher will be observing during the activity to make sure that's not happening. Each group also has clear goals. They knew their objective going in. It was stated at the beginning of the lesson. They know they have to get 6 of their 8 problems correct, and they need to work together on any ones that are challenging to make sure that they are able to submit an answer without asking other groups or without really referencing the teacher unless it's a specific question, which does happen.